So again, what I sent you this morning was this, and I'm going to go over it right now. I'm going to bring it up on the screen. Do I expect it to 100% make sense to you? No. There's also a few things that I put in there that are not even really that well explained in the book, but I just added some of my own stuff in there. All right. Again, whether that's a good thing or a bad thing, I guess remains to be seen. But this is it. So I want you to first take a look over here. And again, you have this, so you can bring it up if you want to. All right, but you'll notice I've got an employee class. What is that? Well, notice when you look at it, it's abstract, which means that we cannot create an instance of the employee class. All right, and what does it have in there? It's got three constants. I've got a minimum employee number, a maximum employee number, and a default employee number. Now, that may sound stupid because it is possible in here, in the way that I've written this, that more than one employee can have the same employee number. That's not what you should do, of course, but I would be able to go in and check, and anyone who had an employee number of 9999, I would know it wasn't set. So I would have to go back in later and manually reset it. That's kind of my rationale for doing it this way. And if you look right here, let's assume that this company just goes nutso. You know, it becomes a mini Amazon. Well, all I have to do then is take and start adding zeros onto the line that you see right here, and now I can have more employees. All right. Now, I didn't put in a really refined structure in here. It wouldn't have been that hard. That every time I create an employee, I could have just taken had something that had a current employee number and added one to it. We could have done something like that. So there's a lot of different ways that this could be done, is what I'm trying to tell you. All right. And I'm assuming here that each employee for this company, and there's 4 types. I've talked to you about this last week. So again, there are hourly employees, there are piece worker employees, there are commission employees, and there are salaried employees. I would assume that typically hourly employees and piecework employees probably would be union. Now, that's not necessarily the case, but in many companies, that is the kind of case, the way that it's set up. All right. I would also assume that in most companies, salaried employees and commission employees are not union. But I didn't put that in there that it had to be like that. So in other words, I'm saying that every employee who works for this company, regardless of which of those 4 departments they are in, has a first name, a middle initial, a last name, a Boolean that represents whether they're union or non-union, an integer for the employee number. And I struggle with this, whether to make employee number an integer or not. The advantage of making it an integer is if somebody puts a non-numeric value in, the program will immediately blow up. The disadvantage of doing that is now technically I put a field in there that it would be possible to use and actually do arithmetic calculations on. Again, I was always taught that the fields that you make that are int, double, decimal, float, etc., they should be fields that could potentially be used in an arithmetic way. Employee number is not like that. But I put it in there like that, like I said, just to guarantee that it would be numeric. Once we get into talking about databases after the break, you'll see that typically you set data types up. And when you set a data type up, if you say, for example, like in this case, it would be numeric, then as soon as you put something non-numeric in, you try to save it, boom, it's just going to blow up. That's kind of what this program will do as well. All right. Okay. So again, these are the 1, 2, 3, 4, 5, 6 things that every employee has. Now, what you'll notice in just a second when we go through the full Arc Constructor, those are the only 6 we put in there. We don't put in a gross pay because that's something that's calculated in the program. You'll also find that when you are working in a database, typically you don't take fields that you calculate and put them into as database fields. You want to make sure that what's called the state of an object. You know, what's your state right now? Well, it's your current height, your current weight, your current this, your current that. You want to make sure that the current state of an object is as up to date as possible. All right. So again, and notice that the double is the gross pay is the only one in there that's protected. First name, I have no idea why I made that public, probably just to show you could, but it really should have been private. All right, I should have changed that. I didn't. The program works fine the way it is. All right, so with a no arc constructor, notice what I'm doing in here. I've got a first name, a middle initial, a last name, a union, and an employee number. First name, middle initial, last name, union, and employee number. So what I'm doing with these 5 out of 6 fields is if you try to create a brand new employee object and you don't put anything in, I had 2 choices, 2 things I could do. I could either make the program blow up, really 3 choices. I could try to handle it with, by sticking them in a loop, all right? Or I could basically say, well, you know what, I'm just going to put some default values in there. And there's really other ways that it could have been handled as well. So UFN is just unknown first name, asterisk for the middle initial, and ULN for the last name. Now, looking back on this, if you look right here, probably I should have taken that field right there, and instead of making a string, I should have made it a char, because a char is just 1 character. Now you've got your choice. You literally could put in a whole middle name as opposed to a middle initial. And also, there are people in the world that do not have a middle initial. All right. So I said, I'm going to assume you're not union. And notice I wrote over on the side here, unnecessary. And the reason that I wrote that is that's what it defaults to anyway. So you'll notice that if I go and click on the lightning bolt, it'll say fix formatting. I can get rid of it if I want to, but I'm going to leave it there anyway. All right. And then the employee number is that default, that 9999. All right. So this is, again, this is if I create any kind of employee and don't fill in the requisite information. All right. Okay. Then here's our full arc constructor. There should be nothing in here that's new. You'll notice I used different names, didn't have to. Again, this could have been first name, middle initial, last name, etc. We could have done it that way. But just to show you again that there are multiple ways of doing the same thing, this is how I did it. All right. Then for each one of these, what do we have? I'd use the old-fashioned, the getter which just returned it, the setter which set the value to it. Same thing with middle initial, same thing with last name, same thing with is union. You'll notice that how does is union change? Since it's a Boolean, I've got to make sure I set the type, return type to Boolean. All right, and same thing here with integer. Now, there is a little bit of smarts, so to speak, built in here, all right, because it says if the employee number we entered was less than the minimum, which was 1,000, or it's greater than the maximum, which I think was 10,000, we set it to 9999. Otherwise, we accept it. The program will blow up, though, I believe, if I put in something non-numeric there. All right? Okay. And notice this. This is something fairly new then. Because this is an abstract class, right there, it can hold abstract methods. Our abstract method in this case is calculate earnings. What that means is any class that inherits from our employee class must put in a method called calculate earnings. It must return a double. Hopefully that makes sense to everybody. You have to do it that way. Those are the rules that you have to follow. All right. Any questions at all on this class? Anything that doesn't make sense? All right. Then next, I'm just going to run through the 4 classes, and I'm going to show you these exceptions that I created. So let's start with hourly. You've seen this kind of thing before. And notice, class hourly : employee. An hourly employee is an employee. So it is inheriting from employee. These are constants that I set up. You've seen this kind of thing before. I'm not going to go over it. We've talked about this stuff before, and there are comments in there. Hopefully that all makes at least some sense to you. All right. Now, here are 2 instance variables. So these 2 variables right here are unique to employees that are of type hourly. Only hourly employees have an hours worked and an hourly rate. Everybody else, their earnings are going to be set up differently. So you'll notice with the no Arc Constructor, the only thing we have to worry about is this, setting the default hours and the default rate. And then we can call calculate earnings, which we'll look at in just a minute. But notice with this, with our full Arc Constructor, we still need first name, middle initial, last name, is union, employee number. So what's new here are these two, but we're telling the system again, hey, with these first 5 parameters, have the parent handle them. And the parent, again, in this case, is employee. So have employee handle first name, middle initial, last name, is union, and employee number. And I'll handle the hours worked and the hourly rate. And you'll notice with this, what do I have? I'm calling 2 routines to do this. Validate hours worked and validate hourly rate. All right, in the full Arc Constructor. I'm doing that, I'm calling it right from there. All right, that's not these routines. Notice that hours worked also calls validate hours worked, and hourly rate also calls validate hourly rate. And again, there are a multiple number of ways of handling this. All right, but let's take a look at both of these routines. There's really not a lot of code in here that you haven't seen before in other examples. All right, but we're sticking it inside of a class method here. So it's assuming that with this hours worked, we passed in, that was the value that when we tried to create the instance of the class, that was the value for hours worked. So we try to parse it. Remember, if you parse it, this line right here, line 81, will either A, succeed, or B, fail. All right? If it fails, we're handling it here. So if it fails, if it returns false, I just used an out of range exception, out of range hours exception here. All right? Are there other ways we could have done it? Of course, there are other ways we could have done it. It might have been better off, other than an out of range hours exception, to call some other exception. The point is this, out of range hours exception. That doesn't exist. That's something I created. In fact, if you look over here, now if you look over on the side, there's something over here that's called out of work or out of range hours exception. This is how you create your own exceptions using C#. You create a new class, you give it whatever name, but it can't be the name of an existing exception. You can't do that. And it has to inherit from the exception class. All right, then you put in your message here. Hours worked must be between 0 and 84. And you call the parent and you pass that message up to the parent. That's really all there is to it. And I could go over each one of these exceptions, but they're all doing the same thing. The only thing that's different is the message that's being passed. In one case, it says hours worked must be between 0 and 84. The next one will say hourly rate must be between 0 and 100. The next one will say that the number of pieces per hour must be in this range. Then the price per piece must be within this range. Then the salary must be within this range. And the commission rate must be within this range. And the sales per week for commission must be within this range. So they're all basically running the same way. Could I have written a generic method to do this? The answer is yes, but it might have been confusing for anybody running the program. Also, the way I set this up, and you're going to see it in a minute, I think I showed you this even the other day, that I've set it up so if it does get any of those exceptions, the program just blows up right there. We could have handled it so that it would have done this, but then gone back, just done a return or whatever. I decided not to do that so I could really show you what happened when we put in bad data. So I'm going to run it in just a couple minutes and show you an example of each one of the bad datas, so to speak. All right, so we went over the employee, we went over the hourly. Let's look at the piece worker. All right. So much of it will look the same, except these are things that these are constants that are specific to piece workers. So I'm assuming that in 1 hour, the least number of pieces that somebody can make are 0. All right, and I'm assuming the most they can make in an hour are 100. I'm assuming that at a minimum, or that at default, they'll make a quarter of them, 25. The price per piece can be as low as 0. It probably wouldn't be. I don't know why people would be working when they're not getting paid for it. But the most they can make per piece is $1. So when you look at it, if this is the max number of pieces they can make, and this is the maximum price per piece, that's saying that our piece workers can make a maximum of $100 an hour. All right, not a bad day's work, but you get the idea. All right. And we're saying that the default price per piece is 50 cents. Then we've got these two things. The pieces per hour and the price per piece. Now, again, that probably should have been a decimal, but the program works fine the way it is. All right, I can nitpick your programs or my programs or any program and find things that could make it better. All right, but notice pieces per hour. I'm assuming you don't get paid for part of a piece. That's why that's an integer. So here is our no Arc constructor. So all that's doing is it's doing these two things because it's automatically going to be calling the no Arc constructor for our parent. All right. And then we calculate the earnings, which we'll look at in a minute. This is the full Arc constructor. And again, all right, we're telling the parent, you handle these 5 fields. You handle first name, middle initial, last name, is union, and employee number. I'm not doing any checks in here, all right? And basically, I should be doing more checks than I am for some of these fields. It's already taken on a life of its own, and I don't know how many lines are in here, but if you told me 1,000 total, I'd believe you, all right? So then here's our getter. With our setter, we validate the pieces per hour. Here's our price per piece, and again, we validate the price per piece. So again, I do the same kind of thing. I attempt to parse this. If I can't, I throw my own, all right, out of range pieces per hour exception. All right, and I do the same kind of thing checking in here. All right, otherwise, everything's cool. So I just set it the way we have been. Then I do the same exact type of thing in here, all right? And you'll notice, because I guess I probably didn't show it on the last one, what am I doing here? I'm overriding the toString method. I want it to say what I want it to say, all right? And I probably, I think it was overridden also, for the hourly. There it is. All right? And I just wanted to print out all of the information for an employee, for lack of better words. And again, you're going to see this in just a minute. So that was the hourly. This is the piece worker, but it's doing a lot of the same stuff. All right. Then the other two classes. First, we had a salaried worker. And as you can see, I said the minimum salary per week was $1,000. The maximum was $20,000. The default was $5,000. The number of weeks in a year, anybody have any idea why I set it to that? Can't hear you. Yeah, but why the 0.1429? Technically, that'll handle leap years. There's other ways that I could have done it too. I could have just left it at 52. All right. And the default salary is 50,000. Okay. Then again, stuff that's specific to a salaried employee, a weekly salary, and then I don't know why I think this is their salary over a year. All right. Then again, same kind of thing. If you don't put anything in there, we set it to the default and we calculate your earnings just the same way we did before. The parent class, the employee will handle first name, middle initial, last name, is union, and employee number. We will handle just that weekly salary. And we validate that. How? Well, we validate it to make sure it's within range. Again, you're seeing a pattern here, hopefully, all right, that all of these classes are looking very similar to one another. That was done purposely. All right. And again, there's our calculate earnings. Well, that's pretty easy. Weekly salary times weeks in a year. Boom. All right. And then we've got our toString. Finally, the last one that's in here is our commission employee, but it's more of the same. A commission employee has two different pieces of information. A commission rate, which must be between 10% and 33%, and a weekly sales, which must be between 0 and 10,000. Again, those are all arbitrary values that I came up with. All right, they could easily be changed and swapped out for something else if we wanted to do that. All right. And again, what are we doing? Again, we're telling the parent to handle those 5 fields. We're handling these 2, and we are validating them to make sure that our commission rate is within range, that our weekly sales is within range. All right, and again, we've got our overridden toString method right there. All right, that's those. I'm not going to run over all of those exceptions, but I am going to go over the main program, which is in here, okay? So did you notice, or maybe you didn't, I created a library for these so that later if I want to be able to go and put those into instead of a console app, either a GUI app or another app, I've now got a library for them. All right. And then in here, this is the main program itself. And again, it's very similar to stuff we've done in the past. Notice I create 4 different kinds of employees. I've got a list of hourlies, a list of piece workers, a list of salaried, and a list of commission. Why don't I have a list of employees? Why don't I have a list of the one called employee?
Because they're all different employees.
You're making it too hard. We said that employee was abstract. Since it's abstract, you can't use the word new with it. All right? You cannot instantiate or create an employee. You can create an hourly, which is a type of employee, or a piece worker, which is a type of employee, or a salaried or a commission, which are both types of employees. But what should happen in here, I don't know what the error is, but if I come in here and try saying this, I'm going to get rid of it right away. Static list, and I'm going to put in here employee equals new employee. It should be giving me an error. Now, you might say, well, it's not, but it really shouldn't work. I should not be able to create one of these. All right. Now, these are static because they're dealing directly with main. So anything that you create as far as variables has to be static if you create it outside of main. All right. Then what I decided to do was to create 2 different examples of each type of employee. So there's me. I'm not a union member. There's my employee number. There's how many hours I worked, and that's how much I make per hour. I even set it up so that it has overtime built in. Then I said John here is a new hourly, so John should have all of those default values. Does that make sense to everybody? Then I did the same kind of thing with piece worker. Put my wife in there, payroll number. She is union, I said. All right, number of pieces, price per piece. All right, and notice I called calculate earnings for me, and I called calculate earnings here. I didn't have to worry about calling it for the NoArc because I'm already calling it inside of the NoArc constructor. What I want you to get out of this, and please look up on the screen, when this line gets hit right here, what the system does is it goes over and it says, okay, do I have something in here called hourly? Yes, I do. Do I have something in here called hourly that assumes like 5 things or has 5 things passed in? All right, yes, I do. And then there's the other 2 that I have to pass in. So it's calling that constructor for me, but for the other employee, it's calling this constructor. All right, which is automatically going to call the constructor of the parent and set that to UFN, asterisk, and ULN, etc. And it's going to set the default for the hours and the default for the rate. Then it'll call calculate earnings based on that. All right, and as you'll see, they're all basically like this. So then I set up 2 salaried employees. All right, one with the full Arc Constructor, one with the no Arc Constructor. Then I do the same thing with commission employees, one with the full Arc Constructor, one with the no Arc Constructor. All right, and the only reason I didn't have to do that, but I wanted to make sure when the program started, there was some information already stored in each one of those lists. That's why. All right, then I call present menu. All right, and what does present menu do? It presents a menu. All right, so it says please enter the key, the enter key, hit the enter key to continue. I did that because I'm constantly clearing the screen, so it's easy for you to read. All right, and after I do that, I put in this is the main menu. It tells you to enter a 1 through a 9, and whatever you put in there, you can read the descriptions yourselves. But this says, hey, if I didn't put in a number between 1 and 9, just give them a nice message that says, please enter a number from 1 to 9 and press enter now. It'll clear the screen and it'll present that menu to them again. So ideally, they're stuck in purgatory, so to speak, until they enter a number between 1 and 9. So if they enter a 1, and you can see I put this stuff in there, I left all that stuff in there because as I was developing it, I was building it a routine at a time. So I started putting some stubs in there just to make sure that they were getting called. That's the only reason. All right. So I go in and I create new hourly employee. Notice in this case, I create new piece worker employee. In this case, I create new salaried employee. In this case, I create new commission employee. All right. That's the first 4. We'll look at them in just a moment. 5 through 8, this says I want to iterate or I want to show all of my hourly employees. This says I want to iterate or show all of my piece worker employees. This one says I want to iterate or show all my salaried employees. This one says I want to iterate or show all my commission employees. That should make sense to everybody. And now, just because I'm a little biting, so to speak, on my own code. If you look, it's not a big thing, but look up on the screen. Notice, iterate, salaried, capital S, commission, capital C, piece worker, capital P, hourly, should have been a capital H right there, just because you should be working from an established protocol, a way of doing things. I didn't, it works, I'm going to just leave it, but I'm just showing you that. All right. Then with each one of these, so what do we want to do? I wrote this and I tried to see if I could write it without using the tag property. I could have used the tag property, but notice what I want to do here is I want to call build generic object. What does that mean? Doesn't that mean that every employee has those 5 fields in common? Every employee has a first name, a middle initial, a last name, an is union, and an employee number. So I want to be able to call that build generic object for all 5. All right. And then after I've done that, so a 1 will mean that it's hourly, a 2 will mean that it's piece worker, a 3 will mean that it's salaried, and a 4 will mean that it's commission. And after I call that build generic object, I just present the menu again. So to build the generic object, again, notice what I'm doing in here. I did do some validation in here. Not a whole lot, but some. There's really no validation to do on the first name, middle initial, all right, etc. last name. We could have done some, all right, but there's not much to do. But notice for the union, I've got a union string. The employee number, I've got a few things I put in here. So what do I want to do? Well, I want to at least let them know that either they're about to enter an hourly or a piece worker or a salaried or a commission. Okay, I'm letting them know that. You didn't have to do that, but I just decided to do that. So again, this is the common stuff for all employees. So enter a first name, and I just did a read line. I made it uppercase, okay? And then I added to this thing called total, which I really probably didn't even need, but that's okay. All right, so there's my middle initial, there's my last name, then my union status, all right? And you'll notice with the employee number, I did do in here an int.parse. If it didn't work, I set the employee number to -999, just to show that it was bad. Again, so many different ways we could have handled this. Now I'm going to come in here, and now I've entered the information in for each type of employee. So I've entered in it doesn't matter what type you are. All of those 5 fields have been entered in for you. Now it's the stuff unique to them. So now if it's a 1, I want to input hourly worker, a 2 piece worker, a 3 salaried, and a 4 commission. So that's going to call each one of those. All right. And you'll notice again, there's a little bit of stuff in here. So for hours worked, all I did was a try parse, and if it didn't work, and here I did another try parse. And the reason is originally I put in a lot more code than this, but when I did, this is already 620 lines. All right. And it was like, at that time, it was like 750 going on 800 lines with all the stuff I put in it. So I kept cutting it down and cutting it down. It may not seem like I cut it down, but I did. All right. So for each one of the employees then, okay, what are we doing? What am I doing here? I'm creating a new employee, and I'm grabbing each piece of that information that we provided. This was what we put in for their first name, their middle initial, their last name, their union status, their employee number, and for hourly, this will be the hours worked and the hourly rate. And that's going to fill everything up for us. Then I do the same kind of thing for each of the other ones. Now notice here, I say here, try to go and fill up the hourly employee. If there's a problem, okay, out of range exception or whatever, it's going to end up throwing that, doing a read line, and I don't even know where it's going to go then. That might be something I should have put in and didn't. But if I get down to here, now I'm ready to calculate the earnings for an hourly employee. Then I do the same kind of thing for a piece worker. Then the same kind of thing for a salaried employee. And then the same kind of thing for a commission employee. So again, this is big. And this is the instantiation for each one of these. Okay? So I instantiate, and then this is where I'm filling up the list, and here I'm going to iterate over them. And I'm just saying print out every one that I've got. So what I'm going to do is I'm going to run this for you in just a second, show you what's in there, then I'm going to add another one to show you that indeed it's been added. All right? This is the kind of thing that, again, eventually, we want to be able to handle it by either using A, a file or files, or B, a database. All right? Because there's no persistence in this. The only thing that persists over different runs are the 2 first employees that are in there because I hard-coded them in. So if I run this then, and I realize it's easier for you to run because again, if there's a way to make this bigger, I don't know what it is. All right, I guess I can do it like that. I guess you can. All right, so can everybody see that? So when I come in there, if I put in a 1, it'll expect a new hourly employee, a 2, etc. But I'm going to do the 5, 6, 7, and 8 first. So if I put in a 5, there's me. All right, you saw I put that in, and you can see that it's even figured out over time. There is the employee that we created that's got all the default stuff set. So that's what's in there. Press enter, boom. It asks me, it says press enter again. I guess I was a little repetitive. But now I'm going to print out my piece workers. Remember, that was my wife, and I said that she made 50 pieces an hour at 75 cents a piece, so she made $37.50 an hour. This was the default for that one. All right. Then next, this was the salaried employee. So Chloe makes $1,000 a week. So her weekly salary is $52,142.90. Because remember, we set that to 54.129. That's why it's a little skewed. All right. And this was the one that was the default. And then finally, this was the one for commission workers. All right. So now notice if I come in here and I'm going to put in a 1. And it tells me I'm about to enter a new hourly employee. All right, so I'll put in here John P. Smith, and we'll say that John is a union guy. His employee number will be 99990. The hours worked, we'll say, will be 40. The hourly rate will be 40. All right, hit enter key to continue. Well, now I want to print out all my employees, and there's John P. Smith. So you can see I've now been able to successfully add to the array list. All right, and I don't want to bore you. I mean, I can do this for each one of the employees, each one of the types. All right, so again, 2, let's make it real fast. So this is a piece worker, Mary L. Jones. Union will say, no, she's not. All right, her number, 33445. Pieces per hour, let's just say she made 100 pieces. All right, price per piece, but she doesn't get paid much for them, so it's 0.25. And now let's print out a 6 and see if Mary Jones is in there, and you can see that she is. All right, I'm not going to do the other 2. Hopefully you'll take my word for it that they work. Now, how could this program be improved? Well, one thing I'm not doing is I could try to figure out total payroll. I could try to figure out total payroll by department or by employee type. All right, so there's a lot of ways that this could be improved. You will notice, though, that if I come in here now, I'm just going to come in and I'll grab one of the ones I haven't used. So let's say we'll do the salary. All right, so I will do the salaried employee, which is a 4. No, a 3. Okay, so enter a first name. I left it blank. A middle initial, I left it blank. All right, doesn't like something in there. All right. Says index was outside of the bounds of the array. That's on me because that's not my error. That's a system error. So there's at least one error in the program that you can see. All right. But that's not what I wanted to show you. Not that I screwed up, but I wanted to show you this. And that is if I come in here and I put in again a 3 and well, that's fine. All right. Now it blew up here. That's mine. That's my exception right there. How do I know? Because it doesn't say system.exception. It's got the name of my library, employee library dot out of range price exception. So my own exception was working right there. There are things in this program that definitely could be improved. All right. And there are things in this program that work pretty well as they are. All right. So you've got that. I'm not saying that you're ever going to do anything with this. I'm not saying this is going to help you work on a homework problem. I'm not saying this is going to help you on the test. But I wanted to be able to run through a big example and run through the stuff that's in there and also not be bogged down with thinking about, oh, well, what should that GUI look like? Because we didn't care. All right, so hold on a sec.